Hi everybody, welcome to this video series that is called AI Lessons from Spam Detection. And today we are going to talk about the topic why spam filters are an AI arms race. So every day, even before you open your inbox, an invisible AI system has probably made hundreds or thousands of decisions on behalf of you. It has already decided which emails are safe, which are kind of suspicious, which are kind of promotionals, or which are definitely spam and therefore should go to the spam box. And most of the time, you'll probably not even notice it. But here is the interesting part of the problem. Even though spam filtering has been going on for a long period of time, it is still not a solved problem. Now, the question is, why is it still not a solved problem? The main reason behind is that the people who are sending the spams are actively learning the system. They change the wordings, they change the domain, they change the formatting, they use each and every tactics that is possible in order to fool the email filtering system. So in this video, I want to explain to you why spam filters are one of the most oldest and practical systems of AI. And we would also look into how filters evolved, why spammers keep adapting, and what this teaches us about real world AI systems. Because spam filtering is just not about filtering the spam, it is also about classifications, it's also about adversarial behaviors, it's also about false positives, it's also about feedback loops, and most important of all is why all AI systems need constant maintenance. So let's start with the simplest version of a spam filter. Imagine a spam filter that uses a checklist. For example, if your email had a suspicious word, I could mark it as spam. If it had too many links, I could also mark it as spam. If it came from an unknown sender, I could mark it as spam, and so forth. And therefore, this is how a rule based spam filter would basically look like. And they're not really learning anything per se. They were rules written by people, and for a while, they really worked reasonably well because a lot of spam was obvious. You would get messages with exaggerated claims, you could get messages with special fonts or strange links, and this rule based filter could catch all of them. But here comes the problem. The problem is once the spammer understood the rules, they changed the spam or they changed their behavior. So if one word got blocked, they would use another word. If a domain got blocked, they would change to another domain. So basically, the filter improved, the spam changed. The spam changed, the filter improved. And you could see that this is already an arms race that has started up. Now let's come to the main idea of the problem. So spam filtering is not like your classroom machine learning problem. So in classroom example, you could train a model that could identify cats and dogs. So the model learns patterns, cats have certain shapes, certain features, and dogs have different, right? But here is the key difference. The cats are not trying to look like dogs. And unlike your classroom machine learning model, here spam is actively trying to look like normal email. And that is why spam filtering is an adversarial machine learning problem. The attacker is not passive. The attacker watches what gets blocked, changes the message, changes the sender identity, changes the structure, and tries again. So the model is not just learning the world, it is actually learning the world where someone is actively trying to manipulate the data. So the filter in turn would learn new signals, the spammer would change the tactics again, and this cycle repeats. And that is why spam filtering is never finished. So you cannot just train a model, deploy it, and walk away. The moment your system works, the attackers have an incentive to adapt. One of the important lessons from spam detection is that accuracy is not enough. So you can imagine a filter that is very good, blocks all spam, but once in a while it blocks something important. For example, a job interview invite or an university admission email. This could be a serious problem, and basically that's the cost of false positive. And imagine now the opposite, that the filter is very relaxed and it allows all suspicious email to inbox. And most of the time it might be annoying, but it could be also dangerous. If it is kind of a phishing email, for example, it could try to steal your password, it could contain a malware, And therefore, it is not just a technical problem anymore, it is also a risk management problem. And different users and organizations have different trade offs. A personal inbox, an hospital, a bank, an university, and a large company may have different tolerance levels. And for some users, missing one important email may be worse than seeing some spam. For other users, one successful phishing attack can be far more dangerous. So the AI system has to balance all the competing cost. So modern spam filtering systems are not just one single model making one simple decision. It is in fact layered architecture. For example, you have multiple layers among which one layer could check the sender reputation. There could be another layer who could check for authentication. There could be another layer who checks the links in the email. There could be attachment scanning in a different layer for viruses. There could be content analysis, and finally a machine learning model that could estimate the risk in the message. So even then, this is not enough. This is because you also need human reviews, security policies, and feedbacks from users. So the best way to look at the spam filtering is not, is there an AI model? In fact, the better question is what surrounds that model. Because in production, the model is just one part of the defense. The actual system includes data collection, labeling, retraining, monitoring, user feedback, and response to new attacks. This is the real machine learning lesson. Now let's talk about generative AI. In the past, it was very easy to detect phishing or spam emails because most of them had kind of strange wordings, bad grammar, or generic message. But with generative AI, things have changed. Now, AI can make unwanted emails look more professional and more believable. It can be also be personalized for a situation or personal person or an entity, and therefore it raises difficulty for both humans and filters. But then the defender could also use such AI systems. It could use models to detect suspicious patterns. It could use it to detect large amount of data, to classify threats and adapt faster. So generative AI is not only helping attackers, it is also helping the defender side. However, as you can see, there is an arms race going on. The attackers adapt, the defenders adapt, and the cycle continues. So, what is the bigger AI lesson here? One of the reasons why I took spam filtering as a practical AI system is because it teaches us something very basic. For starters, it tells us that your final product is not the model. In fact, your final product is the AI system that continues to operate even when the environment around it changes. And in an adversarial setup, this change happens on purpose. So, spam detection teaches us that AI system needs monitoring, and therefore they need feedback loops, they need retraining, they need to think beyond accuracy, they need to handle different kind of mistakes or balance between them, and they need to assume that someone is trying to fool them. And the lessons that we learned from spam detection also falls far beyond email. It also applies to fraud detection, it applies to content moderation, it applies to search ranking, it applies to cybersecurity, it applies to recommendation system, online advertising, and etc. And the bottom line is that any place where person have an incentive to manipulate the system, AI becomes part of an arms race. So next time when you check your spam folder and you find an email there, don't just take it just as a place where the junk email goes. Instead, take it as an evidence of a constant AI battle that is going in the background. On one side, the attacker is trying to get in. On the other side, the filters are learning to stop them. So they are basically showing us how a real world AI system looks like when the opponent is trying to fight back. That's it from this video. If you found this content useful, please don't forget to subscribe to the channel and also share it with your friends and family and co-workers who may also find this content useful. I will be making more videos on practical AI lessons. Thanks for watching.